Section 1.8, Combinations of Functions and Composite Functions. Decide, commit, succeed, unknown. So if we have two functions, f and g, we can add, subtract, multiply, and divide. First, we need to define what it means to add, subtract, multiply, and divide. We're adding two functions, f plus g of x. Then we can write this as f of x plus g of x. If we're subtracting two functions, we can write it as f of x minus g of x. And if we're multiplying, we can write it as f of x times g of x. And then dividing would be f of x divided by g of x, where g of x does not equal to 0. The domain, once we perform these operations, is a set of all real numbers common to the domain of f and g. And so this right here means the domain of f intersected with the domain of g, which just means what do they have in common. Example 1, let f of x equals 4x minus 3 and g of x equals x minus 5. Find each of the following functions and determine the domain for each function. So first, we want to rewrite this the way it's defined. So I have f plus g of x. So I can rewrite this as f of x plus g of x. So here for the function f, we have 4x minus 3, and the function g, we have x minus 5. So I'm going to have f of x, which is 4x minus 3, plus g of x, which is x minus 5. Then we can simplify. 4x plus x would give me 5x, and negative 3 or minus 3 plus negative 5 would give me a minus 8. So the sum of these two functions is equal to 5x minus 8. We want to find the domain. So notice here the domain of f. Here's my function f. Since it's a line, then the domain, there's no fractions, there's no square roots, so the domain would be negative infinity to positive infinity. And then the domain of g, again, there's no fractions or square roots or logarithms. It's a line, so the domain would be negative infinity to positive infinity. So the intersection of these two domains, basically what does this have in common with this? And they have everything in common. So the domain of this function here is negative infinity to positive infinity. Okay, let's look at letter B. So for letter B, we have f of x. We can rewrite this as f of x minus g of x. So f of x in this example is 4x minus 3. That's given here. Minus, I'm going to use a parenthesis, g of x is x minus 5. And you want to use a parenthesis since you're subtracting the entire function. So if we simplify, 4x minus x is 3x. Negative 3 minus a negative 5 will be a positive 5. So negative 3 plus 5 would be plus 2. So f minus g of x is 3x plus 2. And again, the domains here are the same, in negative infinity to positive infinity. So the domain for this function for f minus g is going to be negative infinity to positive infinity. Okay, letter C, we have the product. So I can rewrite this as f of x times g of x. F of x is 4x minus 3, and g of x is x minus 5. 4x times x is 4x squared. 4x times negative 5 is negative 20x, minus 3x plus 15. So the product is equal to 4x squared. Negative 20x minus 3 is negative 23x plus 15. Notice that in our result, we still don't have anything such as a fraction or a square root or logarithm. This is a parabola that opens up, so it looks like a U shape. So that means the domain is still going to be negative infinity to positive infinity. Last, we have the quotient. So we have f of x divided by g of x. So f of x is 4x minus 3. G of x is x minus 5. So f divided by g of x is equal to, we can't simplify any further. So my answer would be 4x minus 3 divided by x minus 5. In our answer here, notice we have a fraction. So to find the numbers that are excluded from the domain, we set the denominator equal to 0. So we get x is equal to 5. So x equals to 5 can't be in domain. So your domain is going to be everything except for 5. So we can write that, I'm going to write it up here. So all the negative numbers all the way to 5. And then starting from 5 all the way to infinity.